Okay, so now we've got another composite here. And so this one's a little bit tricky. But before we get into the details on this, I want to address a different problem first, okay? So let me kind of blow this thing up just a little bit here. And I'm going to put a coordinate system on here. So here. And let's suppose that we've got a circle. And the radius of that circle is 4. And this is maybe, I don't know, a piece of wood or steel. It's cut out in the shape of a circle. But then we cut out a circle out of that guy. Okay. So this is a void right there. And the radius of the void circle is 2. Okay. And the center position for that thing is 2, 0. Okay. Just like that. Now let's ask the question, how can we find the center of mass of that? Well, what we can do is we can treat it like a composite of two pieces where one of those pieces actually has a negative area. Okay, so it's kind of cool. Let me show you how that works out. So we'll call this A, and we'll call our void B. Okay, so I need the area of A. Okay, it's just a circle, pi r squared. R is 4, so that's 16 pi. All right, and it is centered at 0, 0. And then my area for B, again, just a circle, radius 2, so that makes it 4 pi. And it is centered at 2, 0. Okay, now B actually is a negative area, so I'm going to put it in there like that. So when I get ready now to do my position, just like we've done, we're going to have AA plus AB. All right, but it's going to work out like this. We're going to have the AA, which is 16 pi, plus AB, which is negative 4 pi. Okay, so we treated the same thing. We just give it a negative value. Okay, and then up at the top, we need the X position for the first circle, which happens to be 0. And then we need the X position for the second circle, which happens to be 2, but we put in its mass as negative 4 pi. Okay, now we work all that out. The top turns into 8 pi, the bottom turns into 12 pi, and we get 3/4. So 0.75 is the center of that thing. Okay, so that trick we're going to use here in this particular example. Okay, and it's very handy. It's a very handy little trick to have on hand. So let me see if I can move these things out of the way somehow. Oh, look at that. That's awesome. Sweet. Okay, so let's get our head around this. So this is sort of a teardrop shaped thing, except it's got this hole. There's a hole here that's been drilled into it. So it is hollow. Okay. So that's the first thing to make a note of. You can see all the dimensions there. The bottom is a hemisphere, so it's half of a sphere. All right. And then the top is a cone. Okay. Just like that. All right. So get rid of that little thing there. Okay, so what we're going to do is we're going to work this as if it's 4 pieces. Okay, so the first piece we're going to address is the bottom. Okay, so down here. Okay, so we're going to have the hemisphere down here. All right, and I guess we'll call that A. Okay, and then the second piece that we're going to have is going to be the full cone here. All right, so we're going to have that full cone here. Okay. Now, we need the full height of that cone, and you can see it's 50 millimeters in radius at the bottom. It's 25 here. Since it's linear, that means that's half. That means this is half. And so that means what we've got over here, the whole height of this thing is 200, okay? Should write down here, the radius is 50, just like that. Okay, so far so good. Get rid of some of this stuff because my drawing's going to get weird. Okay, now what we're going to do is we're going to subtract this core part. Okay, so we'll come over here. This is the part that we've drilled out, just like this. All right, and its height is still 100. Okay, and the radius down here is 25. Okay, according to that right there. Let me erase this. Okay, and I'm going to move my picture just a little bit. Okay, and then the last piece that we need is we need this top part here. Okay. And the height of that is 100. Okay, now I put them in different colors because what we're going to do when we get ready to find out what is the value for y is we're going to need the mass of A, the y, sorry about that. Then we're going to need AY. Oh, I guess it's Z. Sorry about that. Let me go back. It can be complicated enough. I don't want it to be complicated because I screwed up. Okay, so Z. All right. On the bottom, we're going to have the mass of A plus the mass of B minus the mass of C minus the mass of D. Okay, where, by the way, this is going to be B, C, and D. Okay, so by taking B, C, and D and taking B minus C plus D, then we end up with that top shape there that's got the hole drilled down inside of it. Okay, so again, just in case you're not quite sure what I'm talking about. So here's D on the top. And there's C down inside it like that. Okay. Alrighty, now then what we'll end up doing is we're going to go the mass of A and then AZ plus MB BZ minus the mass of C CZ minus the mass of D DZ. Okay, there we go. Okay, so getting the masses on these things is pretty easy. Now, one thing that's a little bit tricky is we do have different densities here, okay, for the top and the bottom. So we got to watch out for that. All right. On the bottom part there, it's only 4 is the density, and the top part is 8. Okay, so we got to make sure we keep track of that. Okay, so I need another color here. We'll use this one. All right, so we need the mass of the bottom part. Okay, so the mass of A, whoops, had my highlighter up. The mass of A, okay, is the volume of that, which is a half of 4/3 pi r cubed. Okay, just like that. All right. The the mass of my cone. Oh, but plus I need that density term in there. We'll call it D. Hemisphere is what it calls it there. The mass of my cone, MB, is 1/3 base times height. Okay, the area of my base, so that's going to be pi. We'll call it R sub B squared H sub B. Okay, and its density, we'll call it rho C. And then I'm running out of room here. Mass for C, that's just a cylinder. All right, so I've got pi RC squared times the height, C, and its density, rho C. And then finally for D, I'm going to have MD. Again, it's 1/3 base, RD squared, times height, HD, and then rho C on that one as well, okay? All right, now, if you have not memorized these relationships, okay, 4/3 pi r cubed and 1/3 pi r squared h. Okay, those are things that you just need to put into your brain there, okay? That needs to be something that you just know, okay? You could impress people at parties or whatever if you need to, but that's just super handy information to have. Of course, you could Google it, but don't get caught flat-footed. That's considered to be common knowledge. Okay, so you don't want to be the person in a group and you're going, now, how did you know that that was that? Okay, you should just know the volume of a cone and the volume of a sphere. Okay, boom, just learn those. All right, now, let me get rid of that highlighting there, okay? Because what we need, remember, what we need now is the center point for the geometry, okay? Now, the one that's easy here is C, okay? So if we come up to C and we try to get that center point, oops, still have my highlighter up, that center point here, okay, its X is 0, its Y is 0, its Z is just halfway up, so it's just 100 over 2. Okay, so they come 0, 0, 50. Okay, now the others, we've got some options. Okay, we could go through the math and work it all out, or we could go to this page right here, list of centroids, okay? And there's a link to this one, okay? Whoops, where'd it go? Come back. There's a link to this, okay? So we could just come down here and we can be like, okay, so these are all areas. That's cool, that's cool, that's cool, that's cool. Shapes, cuboid, period, prism, 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 right, circular, cylinder. Okay, no, we don't need that. Right, circular, solid cone. Okay, that's what we need. Okay, so it pops up there. You can see the nice picture here, R and H. Okay, and then we come right over here and we can see that the Z component is H over 4. Okay, H over 4 for my cones. And so we can do that. So the center point for B, 0, 0, H, which is 200 over 4. So B becomes 0, 0, 50. Okay, and then for D, 0, 0. Okay, put a line there to keep that out of the way. 0, 0, but again, it's H over 4. However, it's already up in the air up to here, okay? So this point here is already up in the air there. So we got to add on to that, Okay, so it's 100 over 4 plus the distance we were already up, which is 100. Okay, so then D, the point D becomes 0, 0, 125. Okay, all right, now let's go think about our hemisphere part. Okay, solid sphere, hemisphere. There we go. Okay, let's see. Nice. Okay, all right. Let's come over here. And it says 3/8 of R. 3/8 of R. That's what we want right there. Okay. So that means point A is 0, 0, 3/8 of 50. Okay? That's an 8. 3/8 of 50. Okay, so then I'm not going to work any more out on that because this has already gotten kind of long, but we would follow the same procedure, okay, that we have all along. Okay, so I need MAAZ. So I'd have a number there. Here's my AZ. Okay, and then I would need MBBZ. So I'd have a number here, and there's my number there. Okay, and I would need to subtract those two bits. There's my number. There's my number. All right, and then go ahead and use my last color here. So here's my number. Here's my number. Okay, just like that. So the procedure is exactly the same that we would do there. It's just you could see this one is it's just a lot more complicated with all its pieces. All right, now the critical thing that I wanted you to see was about how we use this negative space. Okay, just like that. Okay, so if you've got a hole in something, that's how you do it. You just treat it as a negative area or a negative length or a negative volume or negative mass, something like that. Piece of cake, no problem. Okay, there you go.